Today we'll look at causal comparative research. Causal comparative research necessitates at least two very important variables. What we call the independent variable, the variable that can stand on its own, and the dependent variable, that variable which is dependent on the independent variable. But it's also called so that's the causal loop there. The comparative dimension comes with the insertion of either a moderating variable or an intervening variable which affects the relationship between the moderating and the which affects the relationship between the independent and the dependent variable. So this is the normal framework or research framework of a causal comparative research design. So we need to explain what is meant by the term causal comparative, describe how causal comparative research is similar and different from correlational and experimental research, identify and describe the steps involved in the conduct of causal comparative research, look at the diagram of a design for a causal comparative study, describe threats to internal validity, and recognize causal comparative studies. So what is a causal comparative research? Causal comparative research is also known as ex post facto research. This is the Latin term which means after the fact, which means this is a consequence of reviewing the text, reviewing things after the fact. In this type of research, investigators, researchers attempt to determine the cause or consequences of differences that already exist and are prevalent between or among groups or even individuals. In other words, causal comparative research is an attempt to identify a causative relationship between an independent variable and dependent variable, as has been demonstrated at the beginning of this video. And the relationship between the independent variable and the dependent variable is usually a suggested relationship. It's not always proven because the researcher do not have complete control over the independent variable at this point. There are three types of causal comparative research. One that explores the effect of a particular program or the effects of a particular drug. The other explores the causes of particular results, as well as also the consequences of certain things. So a causal comparative research looks at effects, causes, and consequences. So causal comparative research is very similar to correlation in the sense that both are associational research. Associational research means we are seeking to explore how the variables are related to each other. The only difference between a causal comparative research from a and is actually the tools, statistical tools that are used. In that sense, we will make that more clear as we move forward. Both causal comparative and correlational research attempt to explain phenomena of interest. They both seek to identify variables that are worthy of exploration and often provide guidance for later experimental studies. Maybe it's also already worth saying right now that correlation looks at relationships, how A is related to B. Whereas causal comparative research, if you will, often considers differences, how A is different from B. So if your interest is really how A is related to B, then it's almost automatic that you recourse to correlational research. If your interest is really identifying how A is different from B, then you actually move to causal comparative. Nevertheless, causal comparative research and correlational research does not allow you to manipulate the variables. Even if both attempts to explain and explore causation, one in terms of relationships, the other in terms of differences. A more clear investigation can be, or difference between the two can be made. In causal comparative research, we're typically comparing two or more groups or subjects, and that's the comparative side. It can be done in terms of gender, socioeconomic status, and the like, while correlation requires a score on each variable on each subjects and compares relationships between those scores, whereas causal comparative, as I've said, looks into differences. It involves at least one categorical variable, whereas in correlational research, we need to investigate two or more quantitative variables. And these are differences in statistical measures, quantitative and qualitative. But it's also worth mentioning, perhaps, that even categorical variables can be compared, can be correlated to each other. And in that sense, we will not use the common Pearson product moment correlation, but the chi-square. Third, analyzes data by comparing averages or uses a cross-break tables, whereas in correlation, we analyze data by using scatter plots and correlation coefficients. That's the Pearson product moment correlation, where the R is the perfect R is 1.0 if you would like to go back to statistics. In terms of experimental research, causal comparative and experimental research have similarities too. They both require at least one categorical variable, and both groups compare group performances to determine relationships. Actually, more differences. But the differences between causal comparative and experimental is this. In experimental, the independent variable is manipulated, and therefore there's a difference between the experimental setup and the controlled setup. Or in the instance of a Solomon 4 group design, as we discussed, of R1 and R3. But in causal comparative, there's no manipulation of variables involved. Thus, the causal comparative provide weaker evidence for causation, whereas experimental research, because of the leveling off of between the experimental group and the control group in terms of moderating variables, it will provide stronger evidence for causation. In causal comparative, also, the groups are already formed, and therefore the researcher must consider them. Whereas in experimental, the researcher assigns subjects to treatment groups. That, of course, after balancing off intervening or moderating variables. So how do we do causal comparative researches? Again, for this section, I encourage everyone to look at the chapter of Franken and Wallen on how to design and evaluate research in education, as that book provides very clear detail about the implementation as well as examples and evaluation of research of this nature. So we need to look at problem formulation. Normally in quantitative research, this is stated as, is there a significant difference in the blank in terms of blank? That's normally the format of the causal comparative research. But also we need to select the samples of individuals to be studied depending on the demographic variables or moderating or intervening variables that will be considered. These variables needs to be taken into consideration is in a stratified manner of sampling. And therefore, we cannot simply randomly assign people for groups to be comparable. It has to be the same. So the stratified random sampling is eventually one that will employ that is the most appropriate random sampling method for causal comparative research. But we also need to look at the instrumentation in terms of tests. And most of the time we demand the demographic profiles here because they will be using causal comparative research as well as a Likert type scale. No? And I say Likert type or Likert type scale because that's the one that will provide us with a spectrum. Please take note, and I'd like to say it here, that if your study will not eventually employ the uh, demographic profile, it is technically not encouraged to demand that. No? So in terms of design, the basic design is to select a group that has the independent variable and select another group of subjects that does not have the independent variable. The two groups are then compared on the dependent variable. But of course, that will look like an experimental design. But it's also possible to simply have a independent variable and then to have moderating variables, differences within that singular group, and to use that differences as a means to identify which of the differences affect the dependent variable more. The only thing that, but it will pose some internal validity questions. Of course, it needs to be discussed also what is the difference between external validity and internal validity. Nevertheless, when you look at internal validity, it usually have two weaknesses, the lack of randomization, the inability to manipulate an independent variable because we're only operating with a single group. But the threats there is oftentimes the subject bias occurs because you're the one conducting the research. The location can have an effect on test results as well as the instrument or even the loss of subject or mortality can have internal validity threats. Again, for the discussion on internal validity, Franken and Wallen's How to Design and Evaluate Research will provide an entire chapter trying to discuss these. Now, in terms of data analysis, of course, we construct frequency polygons. We look at means and standard deviations because the variables are quantitative in nature. Normally, it's a independent means, or we operate with the means. And we know that we only operate with the means because the presumption is that we are operating with the normal bell curve, right? So that in that sense, it's a parametric measure. And that's the reason why we provided here two parametric measures. No, the one, and I'd like to check this one, t-test for differences between means can be conducted, but we actually implement t-test for independent samples. It will give us a t-score. We use t-test when we are comparing intervening or moderating variable, two intervening or moderating variables like gender. There's only male and female. Or whether you're looking at two types of officers, commissioned or non-commissioned, or you're looking at believers or non-believers. Those are just comparing two groups, and therefore we implement a t-test for independent samples there. We use an ANOVA or analysis of variance whenever there are three or more groups that we're comparing, like socioeconomic status, poor, middle class, above, rich. That will tell you there's at least three, or ranks when there are three or more ranks involved, or educational qualification when you're looking at bachelor's, master's, doctorate, or when you're looking at, or when you are looking at socioeconomic status, educational attainment, uh, those those. However, though it's not stated here, you need to pay attention that when or in the advent that the analysis of variance becomes positive or significant, when the differences between the groups become significant, when the F value, because that's what you will get, the F value becomes significant, you need to do a Bonfinori or a post hoc analysis as a secondary test to it. By that, we mean you need to explore further possible where the differences occurred, and that's only possible in a Bonfinori or in a post hoc analysis. When, sorry, but when the population doesn't follow a normal bell curve, no? Remember, the presumption is that they follow the normal bell curve. But if the group follows a skewed design, as you can see in front of you, we do not use the t-test or nor the analysis of variance. For t-test, in instances where we're comparing two, we recourse to the Mann-Whitney U-test, whereas for the analysis of variance, we will use the Kruskal-Wallis ANOVA. So there's a name attached to it. Just take note when it happens. So the researcher, however, must remember that demonstrating a relationship between the two variables in terms of differences does not prove that one variable actually causes the other to change in a causal comparative study. And that's something you need to pay attention to. That's why there must be a pre-existing independent variable, years of study, gender, age, etc. There must be an active variables or variables which the research can manipulate, the length and number of sessions, instructional techniques, and the like. So for example, you want to explore the effects caused by membership in a given group. Like, what's the difference in abilities that are caused by gender? Of course, the hypothesis is females have greater amount of linguistic ability than males, but you can only make this hypothesis if there's a corresponding present literature to do so. Another is what causes individuals to join a gang. Then the hypothesis, individuals who are members of a gang have more aggressive personalities than individuals who are not members of the gang. Again, there has to be a corresponding literature in order for you to make that claim. Third case, how students taught by an inquiry method react to propaganda. Students who were taught by the inquiry method are more critical of propaganda than those who were taught by the lecture method. Again, here you'd see that the differences can be articulated. So please take note that causal comparative model is the only model by which we can implement the IVDV or framework in research. The references for this talk is How to Design and Evaluate Research in Education, a comparison of urban teacher characteristics and Wassons, and these websites. If it's okay for you to support the channel, please do so. Please subscribe to Samo't sa Simula. Thank you very much for your participation.